ไม่ได้เรคคอร์ดนี่ไม่ใช่เฉพาะนักศึกษานะอาจารย์ก็ถูกต่อว่านะ จากผู้บริหาร ถ้าไม่ได้เรคคอร์ดเนี่ยนะจริงๆต้องเรคคอร์ดนะฮะโอเคเอ่อ for the phosphorus um uh yeah, it is the nutrient, so we have to be careful the presence of the phosphorus and nitrogens in water, especially in the surface water like a ponds where there is no water movement, no currents, like in a case of river, the ponds or the lakes. There's a very high uh, risk of the nutrients accumulations, which finally could deteriorate the qualities of water in the ponds or in the lakes itself. For water supply, we are supposed to find the inorganic phosphorus less than 5 micrograms per liter. We are not supposed to find in such a very high amount. But in fact, this is not the maximum containment limits, okay? But this is the typical concentrations in water supply. We are not supposed to find in at such a very high concentrations, but this is not the limits that could cause the detrimental effects to the human health. Wastewater normally 2 or 3 milligrams per liter of the inorganic phosphorus is quite common, plus 0.5 to 1 milligrams per liter of the organic phosphorus. They are quite common. This is prior to the phosphorus from the detergents. If we put some waste from the kitchens or from the laundering machines, phosphorus could be greater. In biological process, aerobic process and anaerobic process, we need to maintain the ratios of the BOD to N is to P for about 100 is to 5 is to 1. So the details about the aerobic treatment or aerobic removal process, we will talk about this next week in the next chapter. If the ratio it's not in accordance with 100 is to 5 is to 1, so we have to make up some deficiencies. It is like in the wastewater. In the wastewater,
อาจารย์ครับ
it is like this.
อาจารย์ก็ไม่ได้แชร์สกรีนเหมือนกันครับ
เอ้า แชร์สกรีนอีกแล้ว I was talking about this files ตอนนี้ now you could see my screen. Okay, so now I just moved to the OneNote. ตอนนี้แชร์สกรีนแล้วนะฮะ เห็นแล้วใช่ไหมฮะ
ครับเห็นแล้วครับ
Okay. Wastewater containing some organic substance. So we provide the oxygen, and then by the microorganisms, this organic substance get converted to the harmless end products like carbon dioxide and water molecules. So this is the reactions we usually carry out to purify the wastewater or to remove the contaminants, especially the organic matters from the wastewater. So organic matters normally we measure in terms of the BOD. Yeah, of course we also measure in terms of the COD, but generally speaking, BOD represent the organic substance. This one. So how do we carry out these reactions in realities? So these reactions we must carry out in a vessel or in the reactor. These reactors, it's nothing but just a chamber So there are actually there are three types of the ideal reactors. The first one we call a batch reactors. Batch reactors is nothing but just we dumped everything inside this reactor and let it be. And at the end of the reaction periods, we just open the lids and then collect the products. Like this morning, I was talking about the fermentations of the fish sauces. So we put the fish, we put the salt and inside this containment, and we let it be for at least 1 year. And after that, we only take the liquids and try to filter, try to remove all the suspended matters from the liquids, and finally we will get only the pure fish sources. Fish sauce is a very unique ingredients and very popular in our countries. I'm not sure, but I think other countries they don't have the fish sauce. I have never seen it before. Uh, okay, so this is a kind of the batch reactors. Sometimes the agitation need to be provided, but for the another types of the reactors, we provide mixings, and then there is the inflow and there is the outflows. So the volumes is V. So this one inflows and outflows. Uh, the flow is coming in and out all the time. So this kind of reactors we call a continuous or US and or US. Continuous stirred tank reactor. In short, we call it CSTR. So it's just like this wastewater treatment plants. For large wastewater treatment plants, we also follow we use this kind of reactors to treat the waste. We cannot keep all the waste inside the vessels and let it be for several hours or several days. It is not possible because we don't have the space. So we have to operate the system like this. There is the influence and there is the influence all the times. And then the last one is like a tubular reactors. This is the inlet and this is the outlet. This one we usually call a plug flow. Okay, so there is no mixing in the lateral directions, but as the contaminants moved from one side to the other side, the concentrations will decrease. So this kind of reactors we call a plug flow reactors. The plug flow is quite similar to the flows in the streams or in a river. So if we put something in the rivers here, and then if you measure the concentrations at the end, you will find you will not be able to determine probably the BOD or whatever the contaminants added at the inlet, because some reactions is going on. Finally, some of the contaminants have already been removed or degraded in some way. So for this one, wastewater treatments, it depends on the several factors, but generally speaking, we use this system to treat the waste. So we will talk about this again in the next chapter, but the thing is, this kind of reactors, what we can actually make these reactions becomes real. So we provide the aeration facility. We equip the aeration equipment inside this tank. This nozzle are connected with the aerator or air blower, so that we can actually supply the air, and then wastewater get inside this chamber with the flow rate Q. So this wastewater always contains some organic substance. The organic substance, in terms of the reactor analysis, we normally use S to represent the BOD, or the organic matters concentrations. So here inside this reactor, we also cultivate the bacteria. So now, what else do we need? The oxygens we already provide. Bacteria, we also let them go inside, and then the organic substance come along with the wastewater. So all these three major reactants stay together in this vessel, so that now this reaction is ready to proceed. Okay, so for this bacteria, they actually need the organic substance. They actually need the BOD. Okay, we provide the organic substance for the bacteria. Generally speaking, we can say organic substance is the food for the bacteria. They actually consume this one and then degrade it and grow up, becomes new cells, and then some of them may die off after some times. So the bacteria, their growth, it's very much depending on the presence of the organic substance, and of course the oxygens. So now, if we are talking about the BOD, this one, it's more or less of the food of the bacteria. And bacteria, they are living organisms. They are very similar to the human being. They are very similar to us. We need the food, we need the major nutrients, and we also need the micronutrients. The major nutrients or the micronutrients may be different. First, of course, we need to eat the food, and all the food contains all the major nutrients. But sometimes we also need the micro nutrients, like some kind of heavy metals, zinc, copper, irons. These metals are also important for us, but we cannot consume too much of these metals. Otherwise, it will be harmful to us, to our body. But for the bacteria, what about them? So organic matters could be food for them. That is why I put here as the S. S actually stands for a substrate, or the food for the bacteria. The bacteria, apart from the food, they also need the nutrients. So what are the major nutrients that is required by the bacteria? The major nutrients that is required by the bacteria is N and P. Other kind of metals, they are also the micronutrients. They are also necessary, but the bacteria, they don't require much as compared to the N and P. So N and P must be there along with the food. So wastewater must contain some BOD and N and P. So otherwise, the bacteria will lack of these nutrients, and once they lack of these nutrients, they cannot grow up. And if they cannot grow, they cannot consume the organic substance. And finally, our wastewater will not be treated. So in a wastewater treatment plant, in a wastewater treatment process, one factor which is very important is we need to provide the food, and we also need to provide the nutrients for enhancing the growth of the microorganisms. But if we provide the food for them 100 milligrams per liter, we should provide the nitrogen for the bacteria 5 milligrams per liter, and also phosphorus 1 milligrams per liter. They don't require much nitrogen and phosphorus. So if we could provide the food along with the nutrients in accordance with this ratio, the system will not experience any uh, uh, specific problems. But if we don't have sufficient nitrogen and we don't have sufficient phosphorus, it may affect the growth of the bacteria. And in that case, the operator has to make up the deficiencies. They have to add some nitrogens. They have to add some phosphates to the influence so that the bacteria they gain sufficient nutrients for their growth. So the requirements is 100 is to 5, it's to 1. But the problem is if you really look at the wastewater characteristic, especially the domestic wastewater, you will find, don't look at the high strength, just look at the low strength. The other types of the wastewater, I believed it would be the same. The BOD in the low strength, it's 110. Ammonia and organic nitrogen, total nitrogen is 20. A phosphorus is 4. So if you compare 110, it's to 20, it's to 4, but the requirements is only 100 is to 5, it's to 1. So what will happen if we feed this wastewater into the reactor? Of course, the bacteria will consume this one. This will finish, but 100 required nitrogen only 5 and required the phosphorus only 1. But if we have BOD as much as 110, then how much nitrogen would be required? 5 something, and then this would be 1 point something, not much. So at the end, you can expect very low organic substance or very low BOD. But some certain amounts of nitrogen will be definitely found in the effluents, and of course the nitrogens we also phosphate will also be found in the effluents. So for the domestic wastewater, we don't have to add any extra nutrient, but some industrial waste maybe we have to add. Anyway, this is for a case of the aerobic treatments, but for the anaerobic treatments, COD is to N is to P, it's 600, it's to 5, it's to 1. So we have to measure the phosphorus, and we also have to measure the nitrogens just to check whether the ratio it's following the regulations, not regulations, the recommendations or not. In the slush, especially the slush originated from the biological process. For the digested slush, the sludge which already treated under the anaerobic conditions. At least 1% of the phosphorus is commonly found, and about 1.5% of the phosphorus is also typically found in dry sludge. Now, if we talk about the phosphorus compound, for the phosphorus, especially the inorganic phosphorus, we can actually classify it into two groups, polyphosphate and then the total phosphate. For the orthophosphate, orthophosphates actually refers to anything associated with PO4 minus 3 phosphate. This one is the phosphate. So if there is hydrogens associated with this one and becomes all these, so all these species are recognized as the orthophosphate. This one is recognized as the polyphosphate. So there are various forms of the polyphosphate, but this could be one of the example. For the polyphosphates, if they are there in water, they may change to the orthophosphate. They are all the inorganic compounds, but the phosphorus associated in the cells, as I told you, the cells of the bacteria require nitrogen and phosphorus. Once they uptake the nitrogen and phosphorus, and phosphorus and nitrogen become part of their body, so that phosphorus could be considered as the organic phosphorus. But if it presents in the environment just in a forms like this one we normally call the inorganic phosphorus. In the analysis, we need to convert all of the polyphosphate to the orthophosphate, and only this phosphate, if we add this chemical ammonium molybdate under the acidic conditions, this one will turn to this one. Phosphate will be associated with the ammonium molybdate, becomes these molecules, and released 24 moles of the ammonia. And this one, if we add, this one is thin. Normally, it's a kind of stannous chloride SnCl2, but this one is actually thin. Thin นี่คืออะไรวะตะกั่วนี่มันเลดนะตินนี่คือดีบุกนะฮะแสดงว่าเมื่อวานผมพูดผิดละนะฮะตินนะฮะตินนี่คือดีบุกนะฮะภาษาไทยนะครับดีบุกนี่ก็เป็นแร่ที่มีเยอะนะฮะภูเก็ตพังงานะฮะจนกระทั่งวันนี้นี่นะฮะที่พังงาก็มีอำเภอชื่อว่าท้ายเหมืองนะฮะมีใครเคยไปบ้างอำเภอท้ายเหมืองนะฮะอำเภอท้ายเหมืองนี่เป็นอำเภอที่ไม่ได้ติดเป็นอยู่ขึ้นบนมาอีกหน่อยหนึ่งจากภูเก็ตนะครับอย่างภูเก็ตถ้าเราข้ามสะพานสารสินข้ามไปเนี่ยจะเป็นอำเภอผมเข้าใจว่าเป็นตะกั่วทุ่งนะฮะแล้วก็ขยับมาอีกนิดนึงก็จะเป็นเขตของท้ายเหมืองนะฮะฟังชื่อนะฮะแล้วก็จากท้ายเหมืองก็เป็นตะกั่วป่านะฮะพอดีผมขึ้นลงบ่อยนะก็เลยจะชำนาญนะแถบนั้นนะฮะดีบุกนี่ก็เป็นหนึ่งในแร่ที่เป็นแร่เศรษฐกิจในยุคหนึ่งปัจจุบันนี้ไม่มีแล้วนะฮะเป็นประวัติศาสตร์เฉยๆนะครับokay, so we add this one that stannous chloride under the presence of this, so this will turn it to the molybdenum blue, so you will get the blue color, and then we will measure this blue color under the UV spectrophotometers. If we have high concentrations of the phosphates in water sample, the at the end, after additions of this stannous chloride, you will get the colors like a dark blue. The strength of the colors depends on the concentrations of the phosphates. High concentrations of the phosphates, you can see the dark blue color. Again, inorganic phosphorus is equal to the orthophosphate plus the polyphosphates, and then the total phosphorus is equal to inorganic phosphorus plus the organic phosphorus. Today's experiments, we will do the total phosphorus. We will not go for the specific any one of these. We will only determine the total phosphorus. Actually, orthophosphate, we can also do it, but in the results you will be given this afternoon will only contains the results for the phosphorus determinations. The next one is the sulfate. Sulfur is one of the elements that commonly found on the Earth. One of the most stable forms of the sulfur found under the oxidizing conditions or under the presence of the oxygens is the sulfate. Sulfates is the prime source or the premeasures of the sulfide formations. You may have smelled the rotten eggs gas. That one is the hydrogen sulfide. If you would like to experience the smells of sulfides, you can visit some canals in which the water becomes turned black, and it gives very, very unpleasant smells of the rotten eggs. That one is the hydrogen sulfide. And it's the smells of the hydrogen sulfides. So under the anaerobic conditions, under the absence of the oxygens, sulfate could actually be turned to the hydrogen sulfide. So if there's the oxygen, sulfate will be remained as the sulfate, but under the absence of the oxygens, sulfates will be converted by the bacteria into the sulfide. And sulfides, if we provide the oxygen, if we aerate the water containing hydrogen sulfides, sulfides may be oxidized to becomes the elemental sulfur. So these kind of interactions you can find from the sulfur cycle. As I told you, sulfates under the absence of the oxygens, sulfates can be converted into sulfide by the anaerobic bacteria. But these reactions will complete only when there is the organic matters. It's just like the organic matters act as the electron donor, and sulfate is the electron acceptor. So we need to have both. Sulfate itself cannot be solely converted to the sulfide without the electron donor. Okay, so once it becomes a sulfide, sulfide is actually highly soluble compared to the other gases like methane. Solubilities of methane is not that high. Sulfide and carbon dioxide, their solubilities are more or less the same. When it get dissolved in water, it may be remained as the dissociated forms or undissociated form. This is undissociated forms. Okay, they remain it as the H2S. In fact, this one is more toxic as compared to these forms. They are all sulfide. They are the same actually, but it depends on the pH. So if the pH is high, then we will find this one in the water. But if the pH is low, then we will find this one. Under the pH 7 or approximately within the neutral range, the pH is 8, in between 7 to 8, you will find HS minus. Okay, this one is the most commonly found forms if the pH is in the neutral range. Okay, so this is the presence of sulfide at various pH. So above 7, we will get this form. This one is more toxic, just like ammonia. Ammonia also has two forms, NH3 and NH4 plus. So which one is more toxic? If I ask this kind of question, so it's the same. Undissociated forms of sulfide and undissociated forms of the ammonia or NH3. So these two forms are more toxic because as they are not having a charge plus or minus, so that it can they can diffuse freely through the membranes of the cells, and can actually interfere with the some kind of mechanisms inside the cell, so that they may cause inhibitions to the some growing mechanisms inside the bacterial cells. That's why we have to be careful about this one. It may affect the bacteria. We are not, in fact, we are not concerning about the bacteria in the natures, but we are concerning about the bacteria in the wastewater treatment plant, our system. So if our bacteria are exposed to this kind of compounds, it may not be good. At the end, we may experience the system failures if we have found too high of this. Anyway, maintaining the pH around 7 would be a better idea to keep the presence of H2S minus instead of H2S. The importance of the sulfates concentrations is sulfates. It's very common. You can find sulfates in the wastewater. Sometimes in a low concentration. Sometimes you can find it at a high concentration. If we collect the wastewater and then send it to the treatment plant during wastewater transportations in the plumbing system. Of course, this is the wastewater, and then the oxygen concentrations in the wastewater itself is very low. So normally, oxygen dissolved oxygen in water is 0, so that sulfates can actually get converted to sulfide. Because mostly the wastewater it's under the anaerobic concentrations, and once it get converted to sulfide, if the pH is lower, pH is pH tends to be low for the wastewater. pH tends to be low, especially the domestic wastewater. If it converted to sulfide, though they have a good solubility, but if the pH is low, and then due to some environmental problems, they can exchange between the liquid phase and the gaseous phase. Some of sulfides may get vaporized, and these sulfide uh, 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 and also due to the natures of the sewerage systems operations, whenever we design a sewerage pipe, normally we allow the wastewater flow to the pipes maximums only 40% of the cross-sectional area. So here we allow the wastewater flowing through the pipes occupying only 40% of the cross-sectional areas. We'll always leave some space here to let the air blowing inside. This is different from the tapped water or water supply distribution systems, because water supply water flow under the pressures, but for the wastewater it flows due to the gravity. And once it falls due to the gravity, one thing which is important to maintain the flowing conditions is we have to keep the pressure inside equal to the outside pressures or atmospheric pressures. That is why the plumbing in the building, almost all the buildings, we need to equip the vent pipes. Vent pipes we normally use to flow the air to maintain the atmospheric pressures, or at least to maintain inside and outside pressures to be the same. So oxygen will be there because this is the air. It's just really funny. When like actually it's so pity for them, for the Indian people. They are now looking for the oxygens, but if you think in another way, oxygen is everywhere around us, but it remains only 21%. But it's still enough for the normal people to breathe in and out. But for some patients, maybe they require more concentrated oxygens. But I'm not sure why they really require a lot of oxygens. Some according to the photo in the newspaper or saw in the websites, some patients they just stay inside the cars and then get the oxygens. I don't know what about their health conditions, or maybe they are not feeling well, so they just get the oxygens, pure oxygens directly, so that makes them feel good. I'm not sure, but for us, like whenever we are not feeling well, we have a kind of inhalants. Always, I think most of the Thai people always have the inhalants inside their pocket. ส่วนมากเราใช้อะไรนะยาดมใช่ไหมถ้าเรารู้สึกเวียนหัวนะ คือภาพของการใช้ออกซิเจนในอินเดียเนี่ยมันรู้สึกเหมือนแบบมันยังไงกันนะฮะนั่งอยู่หลังรถก็ดูดดมออกซิเจนนะฮะเลยไม่ค่อยเข้าใจนะในภาพที่เกิดขึ้นนะฮะดูภาพเนี่ยเหมือนมันเป็นกระแสส่วนหนึ่งอาจจะเป็นกระแสแบบเขาเรียกว่าอะไรพากันกักตุนนะฮะเหมือนกับบางช่วงที่แล้วที่เราขาดแคลนหน้ากากอนามัยนะตอนนี้กลายเป็นที่นู่นขาดแคลนไอ้ตัวออกซิเจนนะแต่ว่า situation นี้เราก็ไม่รู้นะฮะแต่พูดถึงว่าsituation ในอินเดียตอนนี้เนี่ยนะฮะก็นะฮะบางคนอาจจะรู้สึกว่าเอ๊ะ ไอการเผาศพในครีเมทอเรียมเนี่ยนะฮะมันเป็นภาพที่น่าหดหู่นะครับอันนี้นอกเรื่องนิดหนึ่งนะฮะในอันนี้ผมไม่แน่ใจว่าany of you have been to India before มีใครไหมเคยไปอินเดียไหมในนี้มีไหมฮะมีใครเคยไปอินเดียไหมไม่มีเลยนะฮะ
มีครับอาจารย์
คุณเคยไปเหรออินเดีย
ผมไปเรียนม.ปลายที่อินเดียมาครับ
ว้าวเหรอเรียนที่ไหนเนี่ย
บังกาโลครับ
แบงกาโลอ๋อ3 ปีเลยเหรอ
ประมาณ4 ปีครับ
4 ปีอ๋อแล้วคุณspeak อะไรอินเดียหรือว่าฮินดี
เขาใช้อังกฤษครับ
อืมบังกาลอนี่มันกรณาตกะใช่ไหมอยู่ทางใต้
ใช่ครับอยู่ทางใต้
อ๋อเหรออ๋อไม่ไกลจากมัทธราชนะฮะเชนไนนะครับคือส่วนมากในอินเดียเนี่ยนะฮะการเผาศพของเขาเผาอย่างนั้นแหละนะฮะเพียงแต่ว่าทุกวันนี้เนี่ยนะจำนวนศพเนี่ยมันเยอะแค่นั้นเองนะครับถ้าคุณไปที่พาราณสีนี่เผากันทั้งวันทั้งคืนนะฮะจะมีคนกลุ่มหนึ่งเนี่ยนะครับที่รู้ตัวว่าตัวเองใกล้ตายเนี่ยนะฮะก็ดันด้นให้ลูกหลานเนี่ยพามานะพักผ่อนรอความตายอยู่ที่ริมแม่น้ำนะฮะตายปุ๊บก็เผาเลยนะเพราะประเพณีของเขาคือเขาเผาในวันเดียวกันกับที่ตายตายปุ๊บเผานะครับไม่ได้เสียเวลามากนะฮะยกเว้นซะว่าวันนี้มันไม่สะดวกจริงๆเขาถึงจะข้ามวันแต่ว่าไม่เก็บสวด5 วัน 7 วันเหมือนของเรานะทีนี้พอมันเยอะปุ๊บมันก็เลยแลดูแบบโอ้โหมีอยู่เยอะแยะเต็มไปหมดแต่ว่าจริงๆแล้วเป็นเรื่องปกติมากสำหรับการเผาศพในรูปแบบนี้นะฮะถ้าเราไปที่พาราณสีเนี่ยนะฮะจะเห็นเป็นแบบคอมมอนมากเลยนะฮะเกี่ยวกับเรื่องอย่างนี้เนี่ยนะฮะแล้วก็จะรู้สึกว่าถ้าเดินเข้าไปใกล้เนี่ยนะฮะจะเหม็นกลิ่นเนื้อไหม้อะไรไหม้นะครับเผาไปเผามานะฮะแขนหลุดขาหลุดนะฮะถ้าเป็นคนที่มีทรัพย์น้อยหน่อยนะครับนะฮะเผายังไม่ทันจะหมดก็สับเปลอก็กวาดลงแม่น้ำหมดเลยนะฮะคนที่มีเงินเยอะหน่อยนะฮะก็จะซื้อฟืนอย่างดีหน่อยนะครับเผาในระยะเวลานานหน่อยนะครับแล้วก็กวาดลงแม่น้ำนะฮะญาติจะไม่เฝ้ารอจนกระทั่งไหม้หมดนะฮะตอนที่มีงานศพเนี่ยส่วนมากก็จะนะครับกลับมานะฮะหลังจากที่เริ่มพิธีหรืออะไรต่างๆไปแล้วนะครับนะฮะแต่ว่าไอ้ที่เราไปบังกาลอเนี่ยน่าจะเป็นเมืองที่มีสภาพที่ดีกว่าที่อื่นนะใช่ไหมโดยทั่วไป
ใช่ครับอาจารย์มันเป็นเหมือนเมืองหลวงทางตอนใต้อีกทีครับอยู่ในรัฐคานาตากา
เหรอผมไม่เคยไปเลยเมืองนี้อินเดียเป็นประเทศที่ผมไปบ่อยที่สุดในบรรดาประเทศทุกประเทศเนี่ยนะฮะแต่ส่วนมากจะขึ้นไปทางเหนือส่วนมากจะไปทางเหนือนะฮะทางใต้เนี่ยผมเคยไปอะไรนะทมิลนาดูแค่ครั้งเดียวนะฮะแต่ว่าก็ทมิลรัฐทางใต้เนี่ยนะฮะโดยทั่วไปผู้คนจะไม่ค่อยทริกกี้เหมือนทางเหนือนะฮะทางเหนือนี่ผู้คนจะค่อนข้างทริกกี้นิดนึงนะฮะเอ่อจริงๆแล้วเป็นประเทศที่สนุกนะฮะสนุกมากนะครับไปประเทศนี้เนี่ยนะฮะเอ่อถ้าใครไปเที่ยวไปท่องเที่ยวไปอะไรเงี้ยนะครับมีอะไรให้น่าตื่นเต้นเยอะดีนะ เหนื่อยนิดนึงนะฮะต่างจากประเทศพัฒนาแล้วนะฮะหลายๆประเทศนะครับใกล้สุดบ้านเราก็อย่างญี่ปุ่นเนี่ยอันนี้ก็อีกอารมณ์หนึ่งนะฮะใครอยากจะสบายนะฮะเห็นความสะอาดสะอ้านความเป็นระเบียบเรียบร้อยนะฮะอินเดียนี่ก็จะอีกอารมณ์หนึ่งแต่ว่าก็จะสนุกทั้งคู่นะครับนะฮะโอเคthe problems with this is if there is the hydrogen sulfides produced and the oxygen gets inside, hydrogen sulfides in combinations with the maybe react with the oxygen and finally becomes the sulfuric acids. So these reactions it's also carried out by the bacteria. We call it sulfide oxidizing bacteria. This one it's actually the a groups of the bacteria called the sulfate reducing bacteria. Sulfates sometimes can be generated from the mites, especially the mites, metal mites. Normally, the metal mites there is a pyrite, FeS2. This is the pyrite. Pyrite is commonly found in the metal mites. Almost all kinds of the metal mites we normally find this one. We have to cover the ores or anything fired with this pyrite. Otherwise, if we expose the materials, the materials which has the pyrites, if we expose these materials with the oxygen and water, we will get the sulfuric acid. So that is why sometimes the leachings from the mites, sometimes if we measure the pH is very low. And if we measure the concentrations of sulfates, the concentrations of sulfate are very high. In the analysis of the sulfates, what we need to do, we need to use the barium chloride. We add the bariums into the water containing sulfates. Bariums will precipitate the sulfates as the bariums or sulfates. This one would create the turbidities. So we do it like this for the sulfates. So we put the waters containing sulfates here in the flask, and then add the acidic buffers. Normally we use the acetate buffers, and then add a spoonful barium chloride into put the spoonful barium chloride into this flask and stir it for 1 minute. And after 1 minute, it turned turbid. The clear waters become a turbid. This gives a turbid. And then we measure the strength of the turbids by using the spectrophotometers at the wavelengths of 420 nanometers. And then we calculate for the concentrations of sulfates. So the equipment used in both phosphorus and sulfates analysis is the spectrophotometers. This is probably the question, the answers to the first questions, first or second question, second questions. Okay, so this is all about the background, and now if we look at the procedures for the analysis, here I also leave the presentation files in the protocol, so you can actually have a look. So just quickly go through these files. These files actually my assistant Kichanon he prepared for all of you. For the sulfates, okay, so this is the equipment called the spectrophotometers. We use this one to determine the phosphorus and sulfates, phosphate, sulfate, iron, manganese. This one is the major equipment we really needs to use. But this equipment will not give you the value. It will give you only the absorbance. It will give you only the absorbance. How much the light is absorbed. For example, if this one turn turbid and we provided lights at this size, and then the detector is located in the another size. So if it turns turbid, the detectors should actually detect less amounts of light passing through these cells. So according to the absorbance value, we have to make use of this, and then we have to determine the concentrations of the sulfates and total phosphorus from this kind of results. So as I told you, these equipments will not give you the value. It will give only the absorbance. That is why during the analysis, before doing the analysis, we have to make a calibration curve. So what is the calibration curve? The calibration curve is something like this. So we prepare known concentrations. For example, 0, 5, the flask containing sulfate at 5 milligrams per liter, 10 milligrams per liter, 15 milligrams per liter, 20, 35, and then the last one is 40. So we prepare the known concentrations of sulfate, and then according to this, we measure the absorbance. So 0, we get the absorbance 0.04. 5 milligrams per liter, we get the absorbance 0.13. So this is the absorbance measures from the spectrophotometers. So according to these information, we will establish the curve. We plot the curve like this. Our x-axis could be our absorbance, and then y-axis could be our concentrations. Or you can make it reverse. It doesn't matter. But anyway, it should give like a linear equations. Y is equal to mx plus c. So first step, dealing or working with the spectrophotometers, we need to prepare the calibration curve. Sulfates, we need to prepare the calibration curve. Phosphates, we also need another calibration curve. So the procedure is like this. So once we have the calibration curve, then we take the sample, which we don't know the concentrations. So the samples, which we don't know the concentrations, we measure the absorbance. We can actually measure the absorbance from the spectrophotometers, and then the values, the absorbance values we obtained from the spectrophotometers, we substitute into these equations. So we look at the values from this graph. So from the absorbance, then we can find the actual concentrations here. This is the case of the water samples or the unknown samples. So this is the way we deal with the spectrophotometers. Similar to some other analytical instruments, sometimes we have to prepare the calibration curves first, and later on we measure, and then we make use of this calibration curve. Okay, so the first steps, we have to prepare this curve. So basically just prepare this one, then read the absorbance, and once we finish, then we measure the sample. Preparations of the calibration curve and the measurements of the samples are the same. So what we have to do while working with our sulfate, so we take 100 ml of the sample, which may contain the various concentrations, and the next step is add 20 milligrams of the buffer solutions, and after that add a barium chloride. So this is the flask, and this one is the water sample. So we stir it here using the magnetic stirrer. This one is our equipment. The storage, it's put it inside. So here is the barium chloride. So once we put it inside, the bariums will react with the sulfates and becomes precipitated forms, and it gives the turbidity as I told you. Here you can see at the beginning it was clear sample, and after additions of the barium colloids and stirred for 1 minute. Here you can see the samples turn turbid. And after that, we put it in this one in the cuvette and clean it properly, dry it, whip it. Don't leave drops of water. Stick it outside the cuvette. So we put the samples in here and then close and read the values, and finally you will get the absorbance. So once we know this curve, and then later on you measure this absorbance, you can determine the concentrations from this curve. You really need this curve. At the very beginnings of the analysis, you need to do the calibration curve. So every time we measure, we have to do the calibration curve. If you have 1 samples, but you have to prepare the calibration curve, you need another 8, at least 8 points. So 8 samples with various concentrations you need to prepare. So if you have 1 samples, you have to prepare another 8 bottles for the calibration curve preparations. If you have 2, you also have to prepare 8 more, like that. So calibration curve need to be prepared every time before doing the analysis. For the sulfates, we measure at the this one 420 nanometers. But for the phosphorus, we also used spectrophotometers, but before measurements, we need to do the digestion method. The digestion will help all the organic phosphorus and inorganic phosphorus get converted into the phosphate. Okay. So we really need to do these steps before the additions of the ammonium molybdate. So the digestion method, we need 50 ml of sample, or if the concentrations is too high, sometimes we need to dilute it. Once we dilute it, finally we have to make up the volumes to 50. It has to be 50. It cannot be 100, or it cannot be less than 50 ml. Even you dilute it, but at the final volumes before the analysis must be 50. So the steps of doing the digestion method is like this. Next, after the sample is prepared, add 1 drops of phenolphthalein indicators. If the red color developed, we have to add a strong acid solution. So if the red colors appear, when we add the phenolphthaleins, if the red colors appears, it means that the pH is above 8.3. Because above 8.3, the phenolphthalein indicators will show the pink or red color. But if it's below 8.3, or it becomes the colorless. So we have to add the strong acids to bring the pH down to the below 8.3. So we add the strong acid solution. So what is the components of the strong acid solutions? You can look at the instruction manual. You can find out the components of these strong acid solutions in the instruction manual. After that, you need to add either this one or this one. Ammonium persulfate or potassium persulfate, but in the labs, I prefer to use this one. I'm not familiar with this one. Normally, I use this one, but it doesn't matter. You can use any of this because the iron involved in the during the digestions is the persulfate. After that, 1 ml of the strong acid solutions need to be added. Here, the strong acid solutions components usually contains 1 liter of this contains 300 ml of the sulfuric acid and 4 ml of the nitric acids. And boil it until the volumes reduce to only 10 ml, from 50 to only 10. So after it get boiled, some amounts of water evaporated. The remaining it's only 10. We take out. We assume that the digestion process is complete. Then we take it out from the hot plate and then added 1 drop of the phenolphthalein indicators again, and then add the sodium hydroxide until the faint pink appear. So now we bring the pH to be higher than 8.3 again. And after that, make up the volumes to be 100 ml. So from 50 reduces to 10, and from 10 then make it up to 100 ml again. Now the digestion process is complete. Then we move to the next steps. The next steps is the colorimetric methods. I have just explained you about the reaction taking place during the digestion step. Phosphate react with the ammonium molybdate, and ammonium phosphate molybdate. If we add a stannous chloride, the colors, blue colors will appear. The strength of the colors depends on the presence of the sulfate. If the concentrations of phosphate, if the concentrations of the phosphate is high, then this become a dark blue. Now, okay, so we add 4 ml of the ammonium molybdate and 10 drops of stannous chloride. Let it be for 10 minutes. Then measure by using the spectrophotometers. But one thing which is the difference from the sulfate analysis is for the phosphorus determinations, phosphate determination, the wavelength should be 690. In the case of the sulfate, it is 420. This one is 690. Iron, for the iron, it is 510. So measurement of this required various wavelength. Of course, we have to prepare this standard curve or calibration curve, the same as the sulfate. But in the case of the phosphorus, you can use like this: 0, 0.51, 1.5, and 2 milligrams per liter. So if you really have a look here, here is 0 milligrams per liter. The colors is not that dark. But for 2 milligrams per liter, it has gone dark. This one is dark blue. And then the strength of the colors increased with respect to the amount of the phosphate present in the water. Okay, so this one is ready for the spectrophotometer measurements of the adsorbents measurement. Once you add phenolphthalein, if the colors turn pink like this, it indicates the pH of the water sample. It's above 8.3. Okay. Finally, from the calibration curve, you can find out the phosphate concentration. So if there is the dilution factor, just multiply it by the dilution factor again later. So these are all about the analytical procedure for the phosphorus and sulfate analysis. Any other things? Okay, for the lab results, so you will be given like this. This is and examples of the lab results. You will be given the information like this: what kind of wastewater to be analyzed, and the wastewater has been collected from the treatment system, what types of the treatment system uses, and also the physical characteristic of the influence and effluents are also given. And here, further sulfate analysis, you will be provided the calibration curve, and from the calibration curve, you probably need to plot and then again measure the water sample, and finally you will get the absorbance, and then from the absorbance you look for the value from this calibration curve. If the influence, the absorbance is a point, so these two, the average value could be a 0.047. 0.47 must be somewhere in between 20 to 25 milligrams per liter, or I assume it would be about 21 milligrams per liter. So if it's 21, but here the dilution factors is 4, so you have to multiply by 4. So 21 into 4 would be 84 milligrams per liters. I'm not sure about this one. Okay, so this is the rated concentrations. You may get this kind of concentrations after using the equipment, but sometimes you have to find the concentrations by yourself. So you may compare the results related from the machines and the results obtained from the calibration curve. Phosphorus is also the same pattern. Calibration curves will be given, and then the samples results will also be given. You may discuss these results by comparing the results with the standards, and you may discuss in the aspects of the system, water and wastewater treatment system. So whether this system could efficiently remove sulfates or not, or could efficiently remove the phosphorus or not. Usually for the aerobic system, sulfate reduction is not possible. I can say that influence and effluence to the aeration tank, the sulfate would be approximately same, but I'm not sure about this one, why it get reduced, why some reduction is there. Okay, this one is the dilution factor 65. Okay, so you should actually discuss with respect to the systems itself, not just comparing with the effluent standards and described only in terms of the percentage of reduction. Okay, I think that is all for today's. Now I need to lift. I'm not sure whether the rains already stopped. This afternoon, there was a very heavy raining here over these areas. I'm not sure about in your place. Do you have any questions? มีคำถามอะไรไหมฮะ For the discussions of the last week lab results, we will do it next week. มีคำถามไหมครับ ถ้าไม่มี
ไม่มี
นะครับ เรา
ครับสวัสดี
เจอ
ครับ
กันนะฮะสัปดาห์หน้านะครับ เชิญลิฟต์ตามอัธยาศัยได้เลยครับ เดี๋ยวผมต้องไปละ
อาจารย์สวัสดีครับ
ครับ ส
ส
วั
วั
ส
ส
ดี
ดี
ครับ
ค่ะ
สวัสดีค่ะ
ครับ